If x is a positive integer, is x odd? Well, we need to check statements. First, we have x over 2 is not an even number. Does that mean that x over 2 is an odd number? That is a possibility, provided that x over 2 is integer. But what happens if x over 2 is not an integer number? Because nothing obliges x to be an integer. X is an integer, but x over 2 is not necessarily an integer. If it is not necessarily an integer, that means it could be a fraction. So we would have two cases: when x over 2 is an odd number, or if x over 2 is a fraction. But consider this: if x over 2 is odd, then it follows that x would be, for example, 2 times an odd number. Let's say, for example, 3. Okay, 2 times 3, this equals 6. So here we have an answer no to the question, because 6 is not odd. What happens if x over 2 is a fraction? Well, certainly fractions are not even nor odd. So what kind of value should x have if x over 2 is a fraction? Well, for example, if x equals 5, then 5 over 2 is a fraction. But 5 itself answers yes to the question. So we have a yes, we have a no. That is called not sufficient. In statement 2, they give a power of a negative base. Minus 4 up to this exponent is a negative integer. So for a negative integer, as a result of this power, that means the exponent should be odd. That's a rule. Remember? If the exponent is odd, that means x should be even. So this gives a certain answer to the question. That is to say, we can say x is not an odd. So sufficient. And the answer choice is B. Second statement alone is sufficient, but first statement alone is not sufficient.